Hi guys, and welcome to another video of my networking series. I'm Devil's IT, and this is the Networking OSI Reference Model Explained. So today I'm going to be taking you through an overview of the model and an explanation of the layers. OSI stands for Open Standards Interconnect and is a 7-layered conceptual model that describes the standards for computer intercommunication. It was designed in 1984 by the International Standards Organization and is still used and relevant today. We're going to start off with the application layer, and this is the layer that's closest to the user and provides an interface that allows for the exchange of data between programs at a source and destination point. The top 3 layers of the OSI model define functions of the TCP/IP model and are often referred to as upper layer data. Examples of this could be the File Transfer Protocol, Hypertext Transfer Protocol, Post Office Protocol, and Internet Message Access Protocol. The presentation layer has 3 primary functions, the first being the presentation of data at a source device. This means formatting data into a compatible layout for the end device, like a phone or a tablet. The second function is the encryption and decryption of data during and after data transmission. And the last function is the compression and decompression of data, so that's suitable for the destination device. Examples of this could be the American Standardized Code for Information Interchange, Portable Network Graphics, or Graphical Interchange Format. Session layer is the 5th layer and is responsible for the creation, maintenance, and termination of communication dialogues between source and destination applications. Examples of this could be your network basic input-output systems, your border gateway protocol, or your server message block. The transport layer establishes temporary logical connections between 2 applications and delivers data between them. It's also responsible for the connection between the upper data layers and the lower layers of the OSI model. The 2 examples of this are the Transmission Control Protocol and the User Datagram Protocol. TCP is reliable and has high latency, which would be good for downloading files, whereas UDP is unreliable but has low latency, which would make it perfect for video conferencing or voice over internet protocol. Network layer allows routing devices to exchange data across different networks, and it does this through 4 functions. The first being IP addressing of end devices so that they can be properly identified on the network. Encapsulation of protocol data units from the transport layer into a packet that can be sent across a network. PDUs units of data that are different at every layer of the model. Routing, selecting best paths across a network towards the destination host using IP addresses. The de-encapsulation of packets once they've reached the destination address so that they're ready for the transport layer to pass up to the upper layer data. Examples of this would be your Internet Protocol version 4 and your Internet Protocol version 6. There are others, but these are the most commonly 2 that are implemented. Your data layer. The data layer provides connections between end devices on the same network and will not venture outside to other networks. It means that they stay local. This layer contains 2 sub-layers known as Media Access Control and Logical Link Control, and these are described on the 802 Local Area Network Standards. The PDU used here are called frames. Your examples, as I said before, is your Ethernet 802.11 and your point-to-point protocol. The last layer is the physical layer, where physical and electrical specifications are described. This layer works purely on a physical level and does not think logically. It doesn't know the meaning of the bits that are being transmitted, it just knows that it needs to send them across the transmission medium, whether that be electrical, wireless, or light. Bits that are represented by 0s and 1s, and it's up to the physical layer to represent that physically. Examples of this could be cabling, passive hubs, repeaters. Okay guys, that's it for this video. I will be uploading more videos in the future that's going to provide a more in-depth look into each of the layers and the communications, but that's it for now. See you guys later.